Hello and welcome. So today is going to be a start of our Unit 8, which is key features. So today specifically in this video, we're going to be talking about domain, range, and end behavior. Alright, so we have two goals for today. I can determine intervals of domain and range graphically, and I can determine the end behavior of a function graphically. Alright, so a function is an expression or rule that defines a relationship of the input, or the x, essentially the x, right, to the output, which is the y. So it's kind of what we've been talking about before, right? If we have f of x, this is represented as a function f of x, right? It is a function of x, meaning if our function were equal to x squared plus 4, for example, this is the rule. It's the law. It's kind of like the requirement for the function to exist, right? And if we plug in x, we should get out y, right? X is the input, y is the output, right? You put in x, we get out y. Remember, f of x is really just a fancy way to say y. Alright, so when we're talking about functions, that's really what it's referring to, is that kind of idea. You plug in x to get out y, or in other words, you have a graph, right? So, domain, it relates to the x values, or the inputs. Alright, well, range domain relates to the y values, or the outputs. Alright, so kind of going with that idea where domain is x, range is y. Alright, so then from there, example 1 is going to be state the domain and range in interval notation for the following graphs. Alright, so we look at this and I'd say, alright, we have ourselves a graph. It's a little fuzzy, but that's okay. Alright, so if domain is the set of all x values, meaning domain is your x values, here is your x-axis. And what domain is really asking for is it saying, for what x values does a graph exist on? So everywhere this graph is, if we were to imagine ourselves squishing the graph down onto the x-axis, where would we see it? Right? For what x values does your graph exist? So I'd say, alright, if we were to squish this down, first off, this is a little special here. This is an open circle. Now remember, open circles mean we don't actually have the value there. So we'll notice that that's at negative 1, 2, 3, 4. That's negative 4. Alright, so negative 4 is where the domain starts, but we can't include it because of the open circle, right? And then we'll notice as we keep pushing that graph down, we'll notice we have graph for all of the x values, all the x values, all the x values, and then we hit the other end of this graph where we see an arrow. And that arrow means it's going to be continuing on forever and ever and ever and ever and ever, right? I don't care necessarily that the graph is going up. Domain only relates to the x values, and I say, alright, even as, that arrow keeps going off over and over and over again, technically, this is still an x comma y point, right? Or we would have some kind of x if we were to squish this sucker back down. Okay, so it may continue forever, but what we really care about is that while it's continuing forever up, it's also continuing forever to the right. So the domain would be negative 4 to positive infinity. Now, the reason why we use positive infinity here is because we'll notice as the graph is going forever in the positive direction, right? It's not going to stop. It's going to keep going. And in this direction is positive x's, so we call it positive infinity. Alright. And then we do the range. Actually, let's focus domain first, and we'll come back for the range. Alright, so domain, let's look at the next graph. Okay, we'll notice on the left side we have an arrow. That means it's going left forever while it is also going up. So it's going to keep going, and eventually it'll hit that negative infinity. And it'll continue all the way to the right side. Well, we'll notice the graph stops at positive 4. Now we have a closed circle there, meaning we have that value. It exists. There's an actual x value that exists for that point. Alright, so the domain would be negative infinity to 4. Our next graph, we'll notice here, is an open circle. It's hitting almost perfectly where it kind of looks like it's closed, but here we'll notice on the right side that is a for sure closed circle. This is an open circle. Alright, so I'd say, alright, x values, meaning the graph starts here. What x value starts there? That's 0. Open circle means we don't actually have that x value. Alright, we just see the graph there is all. Okay, and then it continues on, right? We'll notice we have a graph, 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 and then a graph stops at the x value of 5, right? If we were to squish that down, we'd be stopping at 5. Now 5 is a closed circle, meaning we have the value. So again, domain is just looking to left to right, which x values is there a graph for. Okay, we'll keep it running for example D. Alright, so example D, I'd look to the far left and I'd say, alright, where does my graph start? And when we see this, we'll notice that it's an open circle, and this is at -5. Open circle means we don't have the value, right? And it does a little like zigzaggy things, but right, we won't notice any more open circles until we get all the way to the other side at +5, but no open circle, it is closed, so we have the value. Meaning the graph exists from everywhere from that open circle at -5 to the closed circle at 5. Alright, next one. Example E. So I'm looking at this gem and I'd say excellent. Well, notice here on the furthest left side of the graph, we have an arrow. Alright, now that arrow is looking suspiciously steep on the downward side. While it is still going down, you'll notice that it's still slightly making its way to the left. And that arrow tells you it's going to slightly be making its way to the left forever, meaning that eventually it'll be at -infinity. You'll notice on the farthest right side of the graph that we can see, right, we still have that arrow again. So as far as it's going up, it is still slowly going to the right forever, and eventually it won't get there quickly, but eventually it will hit +infinity. So our domain would be -infinity to +infinity. Now you don't need to remember this too much. Like small fun side note, you can also say that this is something called all real numbers, meaning that for every number, except for the imaginary ones, right, except for the i's, you have a domain for it. Alright, so that would be domain. Alright, tune in for the next video to watch some range.